Atomos is building an in-space logistics network. We will be the FedEx of space, providing on-demand transportation to spacecraft and payloads with our Quark orbital transfer vehicles.
Our customers are satellite operators, legacy telecommunications who need to be repositioned, new operators looking to reduce deployment costs, and government customers seeking dynamic space operations.
To turn all this into reality, we are fielding the first generation of Quark in March 2024. Quark will launch with a companion vehicle Gluon, and with these two spacecraft, we will prove out rendezvous, docking, and refueling.
In Mission 1, we deploy from the Falcon 9, obtain control from our ops center, and begin to commission the spacecraft. We'll complete testing with our Mission 1 customer, change orbit with our novel propulsion system, and separate the spacecraft to let them fly solo. Quark finds Gluon blinking out in the darkness of space and proceeds to dock to it. We will then refuel Quark from Gluon's tanks and ramp up the difficulty of our rendezvous testing. This is a jam-packed mission, which is historically the province of major spacefaring nations.
The two spacecraft we designed are dense with novel features, optimized for in-space logistics. They integrate a wide range of rendezvous, docking, and propulsion subsystems that allow cooperative interfacing between vehicles. Our avionics and power systems enable bidirectional charging between spacecraft and data transfer while docked.
So the spacecraft-to-spacecraft interfaces that we need to provide cost-effective and reliable services to our clients in orbit just didn't exist. So we had to build most of them. For instance, we developed a docking mechanism that allows us to make rigid connections, maneuver, and even provide power to spacecraft via our Quark vehicle. We also developed a system that allows us to extend missions by refueling from our Gluon vehicle. And underlying all of this, we gained early and rigorous confidence in these kind of systems by a development methodology that was simultaneously hardware-rich with frequent testing.
We've also developed cutting-edge flight and ground software systems that use a modern C++ backbone, along with flexible scripting to enable tight development cycles. Our rendezvous systems are world-class and leverage our team's experience working on ISS missions, along with the latest in image processing and data fusion. We can recognize any object out in space and approach it in a safe manner. While developing all these systems, we get immediate feedback on performance via the 5 degree of freedom rendezvous and full vehicle avionics testbeds that we've built.
Keeping an aerospace mission on schedule and within budget is a challenge itself. Last summer, after unsustainable cost and schedule growth with some of our vendors, we decided to bring both spacecraft completely in-house. Within 2 days, we had a concept, and within a month, we had a validated design, and were able to reduce the budget cost from $25 million to $12 million. And this includes all labor and launch for both 100-kilogram spacecraft. 14 months later, we have built both spacecrafts. We are still launching on Transporter 10, and we have stuck to our $12 million budget. We have done all of this with only 30 people.
In the next couple of years, these little spacecraft will do a lot of growing up. This mission demonstrates foundational technologies, which allows us to provide new life to existing satellites and even send missions to the moon or asteroids from low-cost rideshares. Our next-generation Quark vehicles have incredible power densities and thrust levels, setting entirely new standards for electric propulsion spacecraft. We do this by elegantly packing a space station's worth of power into a small sat form factor, with the ability to autonomously capture any spacecraft using our advanced robotics.
That future of in-space transportation starts with this mission, where we're proving out the key technologies needed to revolutionize how missions are designed forever. It will be as significant as when SpaceX first landed and reused their rockets.